show that the gradient is, to find the gradient means to find the dy dx. So to find the dy dx, we need to find dx d theta and dy d theta. So this is x is tangent, so dx d theta, the derivative of tangent is secant squared. This is the MF19 formula, and this is non-MF19. Secant is 1 over cos, so secant squared is the same as 1 over cos squared. So for the y, when we differentiate the y here, we have to use the power rule first. So we bring the power down, we have 2 times, the new power is 2 minus 1, which is 1. So using the power rule, we have this, but since the base is not a simple x or theta, we have to use the chain rule. We have to multiply by the derivative of the base. The derivative of cos is minus sine, so we have to multiply by minus sine because of the chain rule. So in the simplest form, we have minus 2 cos sine. Now we can find dy dx, which is dy d theta dx, because if we cancel out, just like usual fractions, we have dy dx actually. So the dy d theta is this guy here. The d theta dx is, be careful, this is dx d theta. So it's the reciprocal. So this is the d theta dx. And cos times cos squared is cos cubed. We get what we need to prove. Now the next part, gradient maximum value. So notice that this is the maximum value of the gradient, not the maximum value of the curve or the function. So because we are finding the maximum value of the gradient, we are finding the derivative of the gradient equals 0. So gradient is y prime, the derivative of y prime is y double prime. So what we are solving is actually y double prime equals 0. Previously we already know that the y prime is this, so the double prime is, because we have a multiplication u times v, we have to use this product rule. So in short, du dx, we can call it u prime, dv dx v prime. The derivative is u prime v plus v prime u. So that's the formula for the product rule. Since the u is minus 2 sine, the u prime is minus 2 cos, because sine becomes cos. Now since the v is cos cubed, the v prime is, so we use the power rule first. We bring the power down, so we have 3 times, the new power is 2, so just like this. But since the base is cos theta, we have to use chain rule multiplied by the derivative of the base. The derivative of cos is minus sine, so we multiply by minus sine because of the chain rule. And again, we are solving double prime equals 0, so double prime is 0. And when we are solving an addition here, nothing we can do, so we have to factorize, turn it into multiplication. So here we can pull out minus 2 cos squared. So from the first term, we still have cos squared here, and from the second term we pull out minus 2 cos squared, which means we still have minus 3 sine squared. After we factorize, now we have a multiplication, something times something equals 0. We have 2 possibilities, the first thing equals 0 or the second thing equals 0. So from the first thing equals 0, we have minus 2 cos squared equals 0. We can divide by minus 2, and then we take the square root, so we have theta equals inverse cos 0, which is pi over 2. This is rejected because the domain does not include pi over 2. So you see here the domain, the theta cannot be pi over 2, so that's why it's rejected. Now for the second factor, we can move this to the right or subtract both sides by cos squared, and then we divide both sides by 3, divide both sides by cos squared, and then sine over cos is tangent. We take the square root, so we have plus minus. So the theta is actually this is plus minus. That's why we have 2 possibilities in the domain. So we have plus minus pi over 6, but if you look at the graph, obviously this p here, remember we are looking for p here, and the p is obviously negative, so the x we use is the -1, so negative pi over 6. Now since we are not looking for theta, we are looking for x, we have to plug into the original function here. Remember, x is tangent theta, so we plug in minus pi over 6 and use a calculator. We get minus root 3 over 3. Alright, I'll see